Hello everyone, welcome back to Civil Learning Online YouTube channel, and once again I am back with my lectures on inverse Laplace transformation, and we have studied about how to solve the inverse Laplace transformation problem based upon the partial fraction concept, and we have already solved some numerical when the denominator has linear factors. Now here this is second type of question, that is when the denominator has repeated linear factors, and I have also dealt with the concept related to the partial fractions about different types, like when the denominator has linear factor, repeated linear factor, quadratic and improper fraction. You will have the link for that playlist in the description as well as in the I section. Go and watch that video, and without any further delay, let's get started. So let's write down solution here and rewrite the question, that is 1 plus 2p upon p plus 2 whole square times p minus 1 whole square. Now if you have watched my lecture related to the partial fraction when the denominator has repeated linear factor, you can easily solve this. See, we have p plus 2 square, so we are going to write it as a upon p plus 2 plus b upon p plus 2 whole square plus c. Here again we have p minus 1 whole square, so due to that reason here it is square, so we are going to write here c upon p minus 1 plus d upon p minus 1 whole square. Okay, here it were cube, then we have to add one more term, that is plus e upon p minus 1 to the power 3. We have to proceed from power 1, 2 and then to 3, up to 3, if here it were power 3. Now what we will do, again we will do the cross multiplication here, so we will have 1 plus 2p equals to a times this portion will multiply this portion, so on multiplying this p plus 2 will cancel out 1p plus 2, so here we will have one more p plus 2 times p minus 1 whole square plus b times, here this portion will multiply this also, so p plus 2 whole square will get cancelled out, so p minus 1 square plus c times p minus 1 will get cancelled out, so p plus 2 whole square times p minus 1 plus d times p plus 2 whole square. Okay, now again the step is same, we have to make maximum 0, so here it is p plus 2. If we take p equals to minus 2, if p equals to minus 2, so on taking p equals to minus 2 on LHS we will have minus 2 times 2 is minus 4, minus 4 plus 1 is minus 3 equals to this minus 2 and plus 2 will make this 0, and 0 will multiply this portion whole will become 0. Again from here we will have b times minus 2 minus 1, minus 3 square is 9, and plus c times p plus 2, so p plus 2 again this portion will make this 0, and this portion again minus 2 plus 2 0, and 0 is multiplied with d becomes 0, so this portion becomes 0 if we take p equals to minus 2, and from here we will have minus 2, this is 0, and minus 2 plus 1 minus 3 square is 9, so from here we will have b equals to minus 3 upon 9, so 3 times 3 is minus 1 upon 3. Now again if p equals to 1, here it is minus 1, so I am going to take plus 1, so that we will have maximum portion 0. So on taking p equals to minus 1, so this portion will become 0, and we will be able to calculate the value of d. So 1 plus 2 times 1 is 3 equals to d times 1 plus 2 is 3 square is 9, so 3 times 3, from here we will have d equals to 1 upon 3. Now what we will do, after calculating the value of B and D, we are also need to calculate the value of A and C. So how we are going to do this? We are going to now multiply the portion which are inside the bracket, so that we will compare the constants of the variables. See here, we have here 1 plus 2p equals to A times P plus 2 times P square minus 2p plus 1 plus B times P square minus 2p plus 1 plus C times P square plus 4p plus 4 times P minus 1 plus D times P square plus 4p plus 4. Now guys, what we will do here, this is plus 2 at the, we have plus 4 at the end. Let me make you visible. See, now what we will do, we will compare the coefficients. Suppose this p will multiply with this p, this will make it pq, and we have here p square. Let me solve step by step so that I would be able to make you more clear about this. So what we will do here now, we have to do the algebraic multiplication. So A times this p plus 2 is going to multiply p square minus 2p plus p. Let me do some rough now. So I'm going to multiply with p times p square minus 2p plus 1 and plus 2 times p square minus 2p plus 1. We will have here pq minus 2p square plus p plus 2p square minus 2p minus 4p. 2 times 2 is 4p and 2, so plus 2. So we will have here p square, and p square will get cancelled out, so pq and plus, sorry, minus 3p and plus 2. So here we have A times pq minus 3p plus 2 plus B times, again we have p square minus 2p plus 1 plus C times, we are going to multiply p square plus 4p plus 4 with p minus 1. So p times p square plus 4p plus 4 minus 1 times p square plus 4p plus 4. From here we will have pq plus 4p square plus 4p minus p square minus 4p minus 4. So p and 4p will cancel out, so pq plus 4p square and minus p square is plus 3p square and minus 4. I hope you know the algebraic multiplication. So pq plus 3p square minus 4 plus d times p square plus 4p plus 4. Now what we will do, we will do the comparison on both sides so that we will be able to calculate the values. See here, we have 0 on RHS, we have 0 times pq. Okay, we have 0 times pq. So what we will do here, here on this A is going to multiply each and every terms. Similarly B will also multiply each and every terms. Here C is also multiplying each and every terms, and D is also multiplying each and every term, and we are going to do the comparison on RHS and LHS of the coefficients. Here we have 0 times pq, so 0 equals to pq means A, another pq is C here, and we have A plus C, but we don't know the value of neither the value of A and C, so we will move to another variable, that is p square. Let's move to p square. So on comparing the coefficient or the constants of p square on LHS we have 0, because here we have 0 times p square, so 0 equals to p square, so B plus C times 3 C plus D. Okay, and we know the value of b, that is minus 1 upon 3 plus 3c plus d is 1 upon 3. So 1 upon 3 and 1 upon 3 gets cancelled out, and here 3c equals to 0. We have 0 equals to 3c, then here we have c equals to 0. Now we have got the value of c, so on substituting the value of c here, we have 0 equals to a plus 0, that is a equals to 0. Now substitute the value here in this question. We will have here 1 plus 2p upon p plus 2 whole square times p minus 1 whole square equals to a means 0, so 0 by p plus 2 is 0, so leave it. And we have the value of b value is minus 1 by 3, so minus 1 by 3 times 1 upon p plus 2 whole square. Again c is 0, so leave this, and we have d value as 1 upon 3, so plus 1 upon 3 times 1 upon p minus 1 whole square. So now inverse Laplace transformation. So inverse Laplace transformation of this portion will be equal to inverse Laplace transformation of this much and inverse Laplace transformation of this much. Now use the formula, that is minus 1 upon 3 times p plus 2. So p plus 2 is going to be e to the power minus 2t times, and we have square, so square means t. Okay, because we know that inverse Laplace transformation, see here, inverse Laplace transformation of 1 upon p square is going to be t, because that is t to the power n minus 1 upon n minus 1 factorial. We know the formula, we have come to know from the previous lectures. So here we will have in times 3 plus 1 upon 3 times e to the power, again minus 1 means plus t times t. So we can take 1 by 3 t, we 1 by 3 common from both, or you can leave it up to here also, it is up to you. Now let's do one more step, that is t upon 3. I'm going to take this t upon 3 common, so from here we will have minus e to the power minus 2t and plus e to the power t, or you can rearrange it in one more step, that is e to the power t minus e to the power minus 2t times t by 3 in next step, that is up to you. So this is one example. Let's talk about one more example on this concept. So here is second example, and let's start the solution of this numerical, that is writing solution and rewrite the question. We will proceed this with the same steps like we have done in the previous example in the same video, that is minus 2p and p plus 1. Again we have in denominator repeated linear factors, so I am going to write it as a upon p plus 1 plus b upon p minus 2 plus c upon p minus 2 square plus d upon p minus 3. This is same thing like I have discussed in the previous example, like what if we have power 3 and power 4. So this is what we do, and here it is power 1 only, so we have a upon p plus 1. Now do the cross multiplication, that is 21 p minus 33 equals to a times p plus 1 gets cancelled out, so p minus 2 to the power 3 plus b times p plus 1 times p minus 2 square plus c times p plus 1 times p minus 2 plus d times p plus 1. Okay, now we have to assume some values. Now if p equals to positive 2, here it is minus 2, so I have assumed p equals to 2. So if we assume p equals to 2, so this portion will cancelled out, and we will be able to find the value of d. So on LHS we will have 21 times 2 means 42 minus 33 equals to d times 2 plus 1 is 3. On subtracting we will have here 9 equals to d times 3. So 3 times 3 is 9. So d equals to 3. So we have calculated the value of d equals to 3. Now what we will do, we will write again p equals to -1. So on taking p, how we got to know that if we should take p equals to -1? See here, we have to consult to equation once again, and here in equation we have p plus 1. So if we take p equals to -1, if we substitute the value of p equals to -1, this will get converted to 0, and all the other expression which consist of the term p plus 1 will get converted to 0, and that is what we have done. So on doing so, on LHS we will have here 21 times -1 is -21, and -33 equals to, and we have p equals to -1. So -1 -2 is -3 to the power 3. -3 to the power 3 is 3 times 3 27, and minus to the power 3 is minus. Okay, so -27 times a, and we have calculated the value of a. Now we have successfully calculated the value of a and d, and further what we will do now, we have to calculate the value of b and c, and for that we will again resolve the factors now. So what we will do, here we have p minus 3 to the power 3 means pq minus 6p square plus 12p minus 8. I have used the formula that is a minus b to the power 3. Now second expression is p plus 1 times p minus 2 whole square. So p minus 2 whole square, I have used the formula here. Again we have p plus 1 times p minus 2, so do the multiplication, and we have d times p plus 1. Now what we will do, we will compare the coefficients of pq. We are comparing the coefficient of pq here. Nothing means 0 times pq, 0 times p square, and plus 21 times 21 p and minus 33. So on comparing the value of coefficients of pq, from here we have a times pq, so a, and second pq is here because this p will get multiplied with p square, so pq, and b will also be the constant, so or the coefficient, so b times p square pq. From here on multiplying this we will get b times pq. So coefficient of pq are a and b, so a plus b, and here the coefficient of pq on LHS is 0, so 0 equals to a plus b, and we have put the value of a equals to 2. So from here we have got value of b equals to -2. Now we need to find the value of c. So how we are going to find the value of c? We can use either of the three condition, that is either we can take the coefficient of p square, or the coefficient of p, or coefficient of -2. Okay, so we have here p square, so coefficient of p square is c, and here the coefficient of p square is going to be, p square is multiplied with 1 and b, so 1 p square means b, and here a is multiplied with this term, so p square coefficient is -6a, and here coefficient of p square is 0 on LHS, so 0 equals to -6a. Okay, so from here we have p square times b, so plus b, and from here we have plus c, and we have got the value of a and b. So substitute the value now. So -6 times a is 2, plus b means -2 plus c. From here we will got c equals to plus 14, because 6 times 2 is 12, and -12 -2 -14, and this goes to other side of equals to, so positive 12. We have got the value of a, b, c, and d. Now we are going to rewrite the equation, or our question you can say, inverse Laplace transformation of 21p minus 33 upon p plus 1 times p minus 2 to the power 3 will be equals to a, means 2 times inverse Laplace transformation of 1 upon p plus 1. Okay, and we have the value of b equals to -2, so -2 times inverse Laplace transformation of 1 upon p minus 2, and value of c is plus 14 times inverse Laplace transformation of 1 upon p minus 2 whole square, and we have the value of d equals to plus 3 times inverse Laplace transformation of 1 upon p minus 2 to the power 3, and use the bracket here. Now we have got the splitted the denominator or the numerator into different expressions. Now use the formula, that is 2 times we have 1 by p plus 1 means e to the power minus t, minus 2 times p minus 2 means e to the power minus means plus 2t, plus 14 times we have p minus 2 means e to the power 2t times p square means t, plus 3 times e to the power 2t times t square by 2 n minus 1 factorial. So 3 minus 1 means 2 factorial means 2. So we are going to rewrite the expressions as 2 times e to the power minus t, and we can take e to the power 2t common from these three, so plus e to the power 2t common. So from here we will have minus 2 plus 12t plus 3 by 2 times t square, and this is our final answer because we have taken this portion common, and remaining we have this. So this is our final answer. We will discuss about some other examples also related to inverse Laplace transformation, which are in the upcoming videos. So do subscribe the Civil Learning Online YouTube channel, and see you in the next video. Till then, stay safe and take care of yourself.